SHA to everyone. So my name is Slim. I'm the Director of Product at Social Hackers Academy, SHA for short. I'm in charge actually of the, let's say, the students and alumni experience in our bootcamp. So, and SHA is a non-profit, a Greek non-profit organization that started back in 2017. We started with an offline model, and so our bootcamp was on site and completely different from the current one. Then with COVID, we switched to the online model. So everything we do is online, and our team is actually from all over the world, and also our students. So this is a good thing because we can reach more people and we can support more people to get into the tech industry, and this is the main thing we do. So we are trying to support a vulnerable group of people like refugee, asylum seekers with scholarships to get into the tech field, to change their career, to find a job afterward, and so on. Our employability rate so far is 91%. So in an average of 3 months of completing the bootcamp. So we are teaching actually right now full stack web development. We run an AWS Amazon restart program, and we also we are currently running our first blockchain cohort. They are finishing soon. So if some of you guys are with us during this event, good luck for your final project. And yeah, so today we have with us Giorgos and Diamantis from CITE. So I will leave you the stage. You introduce yourself, and then we can start talking about our topic. And thank you again for joining us, guys. It's a real pleasure to have you with us.
Thank you, Slim. I'll start sharing my screen so we have something that we can all see and work our way through. Let me also stop my camera to put some more real estate on the screen. So hope everybody can see what I'm sharing. And well, hello everybody, and thank you for inviting us to participate in this technical event organized by the Social Hackers Academy. My name is Giorgos, CTO at CITE, and along with my colleague and VP of Engineering, Diamantis, we will take you through a guided tour of some single-page application recurring considerations and selected approaches. Please feel free to drop any questions you have as we go through the talk, or keep them for the end. So let's first see what we will cover. A few words about who we are at CITE and a bird's eye view on some of the technologies we like to use. Then we will touch on some single page application characteristics and why these make them attractive in some cases. Then a deeper dive on some selected topics, recurring issues, pitfalls, and challenges. So let's get started. CITE is a software house founded in 2007, and we now have 2 branches in Greece, one in Athens and one in Sparta. We have a team of around 40 associates, primarily engineers and software developers, while we are ISO certified on information security and quality process management. Since we started, we have tackled several projects, both on national as well as the European level, while we also had the opportunity to work on large projects at the other side of the Atlantic. Our core activities are around research, development, operations, and consulting, starting from industrial research, bespoke software implementation, project execution, manpower outsourcing, product implementation, and operations support where it is needed. As a software house, we have used several technologies, selecting the tools that will best tackle the work at hand. Still, to highlight some of our weapons of choice, in the backend, we primarily work with .NET Core, ASP.NET, and C#, while on the Java side, we focus on Spring and Spring Boot. Our mobile development stack started from native Android and iOS applications, extending to cross-platform frameworks like Xamarin and lately React Native. Our browser-based client-side applications have worked their way from server-side rendering technologies to more client-heavy approaches with the use of various frameworks, although our current code base and considerable expertise is primarily with Angular. Building a solution, whether that is a product, a service, a library, or an app, is more than just the code it runs. A quick tour around some selected technologies and standards starts from the data management aspect, where we have worked with a number of relational databases, NoSQL systems, spatial databases for location services, graph databases and their respective query languages and data manipulation tools. There is plenty to be said about cloud enabling technologies, from virtualization and containerization technologies as well as orchestration systems. The delivery and quality assurance aspects, including automated build and test systems, CI/CD pipelines, static code analysis tools, and artifact repositories. And of course, in a time when data is king, business intelligence and reporting tools are very often needed to be integrated to offered solutions. We base our development around existing standards and even participate in consortiums that help promote new ones where needed. We have dived early into distributed computing with Apache Spark, building .NET Core bridges, as well as various other frameworks around project needs. Over the course of the company lifetime, we have addressed needs in various sectors, ranging from banking and education to cultural heritage, law enforcement, and open science. We have applications in the fields of knowledge, digital asset and document management, serious gaming, as well as financial, human resources, and business workflow management. We have field-specific expertise to data analysis and visualization, distributed and cloud processing, geospatial data visualization and handling, location-based services, and resource scheduling. Trying to categorize our software services, they primarily focus on web application, service, and mobile development, as well as interoperability, security, and cloud engineering. Although I cannot go into details about most of our business collaboration, I can briefly highlight some of our homegrown products and frameworks. These start from templates and reusable services, reaching to case management systems, location-based services, data analysis tools, and educational and cultural heritage solutions. One thing all these products and services and projects in general share is the process and life cycle from conception to delivery, starting from the planning phase to the designing and implementation phase, the validation and evaluation process, and their continuous feedback loop. As you will gain more experience, you will also be expected to take part in more parts of the project lifecycle. But now we can zoom out of this introduction and zoom into the topic at hand. And I expect most will already be familiar to some degree, at least, with what a single page application is. Out of Wikipedia, a single page application is a web application or website that interacts with a user by dynamically rewriting the current web page with new data from the web server instead of the default method of a web browser loading entirely new pages. But does it fit my needs? I need to do something. Is it the right choice for me? Well, as always, it depends. And it depends on various factors. I've tried to categorize some of them, and we can start by saying that starting from the development process, it depends on the team expertise. There is a learning curve, a steep, in some frameworks, learning curve in order to be able to properly work with a single page application framework. It also depends on the client applications that will be consuming the business logic that you will be offering from your back end. Also, the technology coupling that you will want to have between your back end and your front end, and the layer of separation between them. Speed-wise, single-page applications are usually more responsive time-wise than others. We can see that, for example, by the fact that we can emphasize on the data transfers in our API calls rather than handle layout, which is handled directly in the user interface, in the client side in the browser. There's plenty of client-side caching patterns that we can utilize. We can offload some tedious, repetitive tasks that would otherwise be burdening the backend all the time, because, well, we can always do that, but frameworks that are usually used for single-page applications offer a lot of functionality and a lot of capabilities in order to bring in some of your business logic into the client side as it fits. They can definitely also because of that, the same reason, become a resource hog. But as always, when it comes to speed, the perception is the key. And single page applications being rich applications running in the client side, we get a lot of opportunities to trick, if you want, or to enable the user to have a better perception of our application and its responsiveness. Security wise, as we push more things in our browser, generally the rule of thumb is that if it lives on the browser, if it lives outside our server, it cannot be trusted. Of course, single page applications usually allow for a centralized or at least horizontal security check approach, but that doesn't change the fact that they also expose more of the server and client side logic to an outsider. So with single page application frameworks comes a lot of formalization. Not that multi-page application frameworks do not bring formalization, but specifically for those frameworks, depending on which one you choose, you may have a higher or lower degree of freedom, and you will need, for the various aspects that you will have to face, understand which one of those levels of freedom best fits what you want to be doing, starting from state management to routes to DOM manipulation and so on. On the rendering side, there are client-side rendering functionality, there is server-side rendering functionality that has been added. Generally, especially for the client-side rendering functionality, there used to be a penalty, somehow of a penalty for the search engine optimization impact that you may had, which is gradually becoming less of an issue. But you do also have the opportunity to have much smoother navigation. But this may require some attention to match the user expectation in terms of navigation, especially when it comes to interacting with external to our application buttons, like the browsers, for example, back and front buttons. Tool-wise and community-wise, for debugging and refactoring, there has been a leap in what you can do with modern development tools available in the browser, or for IDEs that you could use, like Visual Studio Code, or I don't know, the IDE of choice. There are also a lot of libraries, either free and open source or even proprietary, that you can find, reuse, and even contribute in some cases. And for the browser compatibility, because we're talking about a lot of very client-heavy functionality here, browser compatibility-wise, all the modern frameworks has alleviated a lot of pain that we used to have when we were implementing inside the browser. Of course, this is a simplified checklist. It's not meant to be a full comparison. And at this point, I think we can start discussing some topics that we have selected specifically that I think will be of interest. Keep in mind that we will not go into too much details for all of them. The goal primarily is to raise awareness and give you the opportunity to dig deeper. And I trust the presentation, as it is being recorded, you should be able to come back to. So before we start anything else, a word to the wise. Any problem that you're facing, somebody else has faced it before you, and that somebody will have created a solution, an approach for that. And if that approach and that solution has already been standardized, then all for the best. Wherever there is a standard that you can follow, choose that instead of defining or reinventing the wheel yourself. And a very good example of exactly that is the identity management. So in all applications that you will have, there will always be a question about who gets to access my web application and how do I trust them. In addition to that, even if that wasn't a technical challenge in itself, there's a lot of regulatory aspects that have been added, like GDPR. There's a lot of privacy and security considerations. There are protections against identity leaks that you need to be aware of. Multi-factor authentication has come very strongly into play. Social logins that users expect to find in applications. And of course, all that means an increasing maintenance implication for our web application. An approach to this is that of the single sign-on, which is an authentication scheme that will allow a user to log in with a single ID to any of several related yet independent software systems. What makes all those services, those applications related, is that they trust an identity authority. It does not mean that they need to be created, implemented, maintained by the same team or the same company. They just need to put their trust in the same identity provider. And how do they do? They do that with a standard, with OpenID Connect, which is an authentication layer on top of OAuth2, an authorization framework. What this does is that it allows computing clients to verify the identity of an end user based on the authentication performed by the authorization server, and also to obtain basic profile information about the end user in an interoperable and REST-like manner. There are plenty of different authorization code flows, as they're called, so different use cases of how you could use that standard, like the authorization code flow, the implicit flow, resource owner grant flow, the client credentials flow. I want to guide you through one of them, which is the, let's say, the one that is primarily used in browser-based application, and that is the authorization code flow. This will allow us to not keep any secrets in a single page application. It is, of course, a browser-based flow, so it requires an end user to be there and interact. There are also multiple playgrounds that you can use to step through the process, like the one that I have here with OpenID Connect. I have a small diagram that I think could help us go through the process. I've taken this from OAuth2, from AuthZ, which is one of the main identity providers out there offering this. Let's see how we do it. A user comes into the application, they want to log in, they come to our web application. We do not have the concept of a username, a password, nothing that will identify the user. Instead, we forward them to our identity provider. And this identity provider will prompt the user for their credentials and any consents that we may want to ask them to provide before they access our application. They will provide all this information, and the identity provider will send over an authorization code to our application. Our application will use this authorization code along with the client ID and client secret that it has been provided with by the identity provider, to send it over so that it identifies itself to the identity provider, along with the authorization code that identifies the user that wants to access that application. The identity provider will validate all the information and give us back an access token that we can then use to allow the user to continue with their browsing inside their application, now authorized on what they want to be doing. And we can move to a different kind of an authorization flow, which is the client credential flow, which does not require an end user, but rather it primarily focuses around service to service, let's say, communication. We have a service that is an integrating, let's say, service that wants to contact our API. So instead of having a user, a browser, and anything like that, it will directly contact the identity provider, providing the client ID and client secret to identify itself. The identity provider will validate that and issue an access token to that service, which can use from then on that access token to access our API and get all the information that it needs, assuming that it has authenticated itself successfully. But we're talking about access token, but what is an access token? Well, there are two main formats that an access token usually comes as, primarily the JWT token and an OPAC token. I'm going to talk about JWT tokens here because they're more widely used. JWT tokens are, again, standard, which defines a compact and self-contained way of securely transmitting information between parties as a JSON object. What does that mean? It means that it can be used for authorization and information exchange. For authorization, because once the user is logged in and the access token has been issued, each subsequent request can include the JWT token, allowing the user to access the routes, the services, and all the resources that it is permitted to do so based on the token. Single sign-on approaches, as the one we've described, uses JWT because it is small, it has a small overhead, and it has the ability to be easily used across different domains. Information-wise, it can transfer information between parties in a secure fashion. And why? Because it is signed. Signing the JWT using a public-private key pair means that you can validate that the sender is who he says he is, and also that because it is the signature is based on a hash of the payload of the token, you can also verify that it has not been tampered. So you get a token that you know that is issued by the one that it says it has been issued, and nobody modified it in between. So you can trust it. How does it do it? Here I have an example of the structure of a JWT token, just to be able to get a feel of what it actually means to be able to communicate through such a structure. On the side here, on the right side, you get a screenshot of JWT IO that you can use to inspect JWT tokens that you have. And it shows that the JWT token is actually three parts separated by dots. The first one is the header. It has information about the token itself, the type, the signing algorithm used, and so on. The second one, the payload, is the useful one for us. It contains claims, statements about the entity, which will typically be an end user, and any additional data the identity provider has chose to add there. And the last part is the signature, the digital signature validating the rest of the parts. We must remember that tokens are credentials. Anybody that has that JWT token can present themselves as the user for which that token has been issued. So, and also we've seen before, we can inspect the token. No information is hidden. Nothing is secret. All the information is exposed. And also it cannot be changed. So we treat it as we treat a password. It is the credential of the identity that we have authenticated. The way to use it is either adding it to an authorization cookie, or in an HTTP header like the authorization header. And we can continue all our operation based on that inclusion of a JWT token. We've been talking about authentication. We've been mentioning authorization. So what is the difference? OpenID Connect is about authentication, while OAuth 2 is about authorization. Authentication is about who you are. Authorization is about what you can do. Each application has its own rules about what the user can do, and permissions are application specific. They don't belong to an identity provider. So how do we handle that? Usually we will push authentication up and push authorization down. Pushing authentication up means offloading it to identity provider. Pushing authorization down means that our application will handle the permissions and policies as it knows it fits to its business logic. There are two common authorization approaches that are often used, the role-based and the context-based. Role-based, you may have heard of it as RBAC, role-based access control, and context-based, to give some examples. For example, you have an item owner. So I can change my profile information, but nobody else's. Associated with some entities in some contexts, like I can admit students in the class that I teach, but I cannot manage the classes that somebody else teaches. And full access control list, well, you can think of it as a file system, for example. So you explicitly say which users, which groups of users can do specific actions on specific folders and files. And of course, depending on the business logic that you will need to serve, you can have any combination of the above. The policy enforcement difference depending on the authorization context that is available. And just a note here, the roles are not the same as permissions. Roles are, let's say, permission groups, are groups of permissions. And to save some headache and to have some flexibility later on in the application as you're building it, you should strive and check policies against permissions rather than roles. This will give you the flexibility to define additional roles and keep all the authorization policy checking logic stay the same. Final note here, do not leave authorization as an afterthought. It should be baked into your approach for most non-trivial cases. Staying briefly on the aspect of security, it is generally not an easy topic to address. It definitely cannot be addressed in a quick talk that we will have here. It requires an in-depth analysis, broad examination, multiple approaches, and risk assessment, but we can always start at the Open Worldwide Application Security Project, which is the OWASP.org. It is an organization that aggregates security risks and violations that are being observed, and in addition to anything else, it also issues a top 10 as a standard awareness document for developers and web application security. You can see here the top 10 of 2021, and along with the list, it also has a lot of information about what each risk is and how you can alleviate it, how you can work against it, and what measures you can take. This is definitely a very good starting point for everybody. I'm gonna leave security out, and I'm gonna start talking a little bit about caching. There are many different layers of caching and many ways that you could use caching mechanisms, and a lot of layers where caching comes into play where we're talking about web application. I'm gonna choose some of them just to mention them. Firstly, we can talk about HTTP request caching. This is implemented controlling the browser's caching mechanism. It is already there. We can just tamper with it. We can play with it to make it work the way that we want. So we can use the cache control headers in our requests and our responses so that we can control which files and requests can and cannot be cached by the browser, and also the caching policy that will be applied for them. After that, this caching utility is hidden from us. We continue doing the same request that we did, but now the browser may be serving it directly and not reaching the backend. Cookies are, well, are a way that you could cache things, especially small size state, preferences, sessions, and so on. Generally things that you would not want to continuously, that are small enough that you wouldn't mind continuously being pushed back and forth in your communication with the backend. There's also the browser storage, which is not a caching mechanism per se, but it can be used for the purpose. There you have session and local storage, which different in lifetime, although they're both bound to origin with the domain, the port, and the protocol that you're using, but they're primarily intended for non-sensitive data. To take an analogy here, adding credentials to a local storage would be like you putting your password in a text file in your desktop. If somebody has access to your account and your desktop, they can see your password. Remember this analogy when you're thinking about what to store in local storage. Then, of course, there's application in memory caching, well, which is bound to the application lifetime and the rules and scopes that the framework that you use will offer. So there's in many cases, this is a very good approach. It's fitting. But whenever we're talking about caching, we need to think about caching validation too. There's a saying that says that the two hardest things in computer science is naming things, cache and validation, and off by one error. So in this case, it is difficult. There are many issues that you need to be considering about when you're discussing cache and validation. But there are some generally used cache busting techniques for the cases that we're talking about here, about single page application resources that they have. The easiest ones, let's say, are based on file name versioning, the file path versioning, and also perhaps query string, changing the query string when we're requesting a specific resource. Generally, the latter should not be used if there are alternatives, because it is known to have issues, especially with some CDNs and so on. I say it as an option, but also I would urge you to follow one of the other two approaches. And there's always the option to use a bundler that will most probably come with a SPA framework that you choose that will alleviate a lot of the headaches that you will have for cache busting techniques and needs. Just a parting note here, you should avoid caching the index file of your single page application because that way you will not have to deal with cache busting approaches also for your index file, which would bring in the logic that the JavaScript would be served into all your resources and static files would be served into the browser. Moving on, we mentioned a little bit about cookies. What are cookies? They are not the pop-up that you get in every site for ads. They come in different flavors. They have a lot of different usage patterns and security levels. For example, based on lifetime, they may differ to session cookies and persistent cookies. Session cookies will be there while you're browsing, but persistent cookies will be there when you revisit. Origin, well, you have first-party cookies that are managed by the site that you're visiting, or third-party cookies that are originating from a different domain. You have access-based differentiations, which are HTTP only, so they cannot be accessed by any JavaScript code, and secure cookies, which will only be transmitted over HTTPS. They continue being a very valuable go-to solution if for cases that they apply, especially for situations like personalization, user preferences, small size state tracking, anti-forgery, and so on. But whenever you're using cookies, especially about credentials, watch out for cross-site request forgery. Again, something that you can see in OWASP.org, and something that you could dig in a little bit deeper. I'm not going to go into this specific topic in this presentation. But we can move on to something that a lot of you may have already seen. You have an API that you want to call. There is you've tried it with a CURL. We've tried it with Postman. Everything works. You add it into your web application, and finally, there's an error. There's a big red line on your console that says something about the course not allowing what you're trying to do. So what is course? Cross-origin resource sharing is a mechanism that will allow restricted resources on a web page to be accessed from another domain outside the domain from which the first resource was served. And here, pay attention. Certain cross-domain requests, notably AJAX requests, are forbidden by default by the same origin security policy. So by default, AJAX requests, the mechanism that we're using to get our data, are in some situations forbidden by default. So what does that mean, though? How does that work? So let's see an example. We have the client here that wants to do a post request to foo.example/doc, send over an HTTP header in X ping other with a value of ping pong, but it does not know if it should do it. So what the browser will do, it will send a pre-flight request with an options HTTP verb that will describe the request that it wants to do, and expect the server to respond with whether it is allowed to do it or not. The server will respond with information about what kind of verbs, what kind of actions, what kind of headers are allowed for the specific operation, the specific endpoint. And if those match, the browser will continue sending the request. It is important to note here that the server will describe what it allows, but the browser will enforce what it will do. That's why your request worked in CURL. That's why your request may have worked in Postman, and that's why it doesn't work in the browser. This brings in a much bigger problem, a much bigger, let's say, topic that we need to be aware of: the deployment. We should not assume to know where our application will run. We cannot assume what the installation configuration will be, other than the ones that we need to explicitly set, of course. We cannot assume the base URL or the base path of our application. We could be running in mydomain.gr at the root path, or we could be running at a completely different domain under a completely different root path. We cannot assume that our single page application will run on the same domain as our underpinning API, hence the course issue. Generally, it would be good to use the configuration options that are available by our single page application framework of choice, so that we can achieve what we want, configurability at the level of the deployment description. But in order to achieve that to a full extent, you may need to have a deep dive into your application framework guts. Let's move on, since we were discussing about HTTP requests and status codes. HTTP status codes is the web API lingua franca. So you may have already seen it. There are 5 big categories of status codes. What lives in the range of 100 is informational responses. In the range of 200 are successful responses. 300 are redirections. 400 are client error messages, and 500 are server error messages. You should use that within the context and for the purpose that they were built. Some things that you very often see and you need to be aware of. For example, there's often the case where an API will return a 200, so a success response, but within the body of the response, it will indicate an error. Or because of misunderstanding between the unauthorized and forbidden, an API might send back unauthorized instead of forbidden. Server-side errors could be used instead of bad requests, so 500 instead of 400 for validation issues, and generally inconsistent usage of status codes. Let's see an example of how something like that might actually create an issue. Although it's a little bit far-fetched, it's something that we have actually seen. A user comes in and they want to use the application. So they will come in, join, click on the login button, provide the username and password, and they will get into the application, see the menu, and decide to click on one of the menu items. This will take them to a root/sensitive view. And there, unfortunately, that route is something that they cannot see. They're not authorized to see it. It's beyond their authorization level. But the backend will generate a 401 instead of 403. So it will say that it is unauthorized instead of forbidden for that resource. So your single page application correctly will say that, well, since it is 401, that means that they're not logged in. I need to put them back to the login form. I send them back, and I also add in a query string that I want the return URL to be back to my view. So I'm gonna help out the user to come back after they log in where they originally wanted to be. But the login screen will see that you're already authenticated, so it will say that you can go back directly to the return URL. And now you have created a vicious cycle, because this cycle will continue to go on until the browser will cut it, because it will detect the too many redirects error, which you might have seen in some cases. So although this is a far-fetched example, it's a very good showcase of how semantics of the status codes should be respected for what they intend to provide. Talking about errors, talking about messages to the end users, let's talk about message handling, error message handling. And we'll start with validation. You need to validate early and you need to validate always. Validation will always happen in two places. Firstly, close to the user, to the front end, because there it is most helpful to the end user, and close to the data because it is required for application integrity. If somebody put the gun to your head and said you can only do one, you need to do the backend validation, because data integrity is key. But you for UI and UX and general user to be helpful to the user, you need to have both. The front end, though, must be able to handle and present errors that the backend will generate with logic that the UI does not have. So how do we handle error messages that we don't know how to interpret? We need to keep in mind that our users are not there to debug our applications with us. We need to avoid blindly presenting any error messages that the backend sends, and rely on the status codes and explicit error codes that the backend will need to send over. The status codes and error codes are as much part of the API contract as is the input and output. An example here, it is taken from ASP.NET, although it is reserved for development process, an error page that will show you a lot of information about what may have happened wrong while you were trying to do something. But still, the concept is the same. The information that you could get could include a system level error message, could display, could have information about connection strings. It could generally expose information that the user, firstly, and that's the simple case, do not want to see, and the bad case, that should not see because it is sensitive information. So you need to be very careful about how you handle the responses from your backend. Now I'm going to jump off to another topic, which is about reusability and be able to identify what you can reuse and how. Firstly, let's talk about controls. When you start an application, you will need to pick your control base. So whether that is simple HTML components like input elements and so on, or if it is Bootstrap classes or your favorite library that implements material design, this is your library, this is your arsenal. But there may be cases where what you need to be doing that is not covered by your existing arsenal. So of course, you've seen it probably already. GitHub is only a search away. You can find there are a lot of things that other people have done, but you should not dive into the first thing you find. Take some time, do some window shopping, understand what everything does, how it does it, if it fits your need, and also, very importantly, respect the licenses by which people have uploaded their code or their artifacts there. There's always the reusability of the clipboard, you know what I mean, but you should never copy before you understand what you're going to be pasting. You may be adding more headaches and more problems than the one that you're trying to solve. Now, assuming that you now want to create a component yourself, what should you primarily be targeting? Chances are that you will not need yet another text input control, but you may need something that is very related to a business or application component that solves a specific case or repeatable case that you have inside your application. That should be the first level of componentization that you will try to tackle. Generally, you should avoid generalizing too early, but with experience, this will become definitely a lot simpler. And there's plenty to be said about that in the rules of optimizations. I will mention them briefly later on. When we're talking about componentization and creating components to be reused, you should always think about encapsulation. You should bake in all the logic that makes the component reusable, but you should not overbake it. So as a rule of thumb, starting off a little bit simplified, if something is too specific inside your component, then it should be configurable. Somebody that is using your component should be able to choose how to behave. If it cannot be parameterized, then you may start considering that it is actually a different component. Moving on, internationalization and localization. Internationalization, other than being a challenge to pronounce, is also the process of designing and preparing your project for use in different locales around the world. Localization, on the other hand, is the process of building versions of your project for different locales. The localization process includes the following actions: extract text from translation into different languages, format data to specific locales. A locale itself is actually what determines the format and the parsing of measurement units, date, time, number, currencies, translated names. Time zones definitely come into play here, languages and countries that you will see. The truth is that modern frameworks make it actually much simpler to think about globalization directly from the beginning. And the localization process will make you think closer to your end user. So you have two things to gain out of this. Firstly, your application will be locale ready, will be internationalized, and also have some locales that you already have put in order to see what you're building. And also, it will take you through a mental process that will take you closer to your end user and how they will receive the information that you have for them. Continuing, a structure is inside your application is both for the developer and for your user. Single page application, firstly, doesn't mean unstructured. So you need to modularize and follow consistent organizational structure within your application. You can group and isolate related functionality. This will help you discover what you need to work on at any point in time. And it will also be a very big assistance while you're doing refactoring and checking the encapsulation of the features that you have. You are not writing just for your users, you are also writing for future maintenance, and this definitely includes yourself too. Then, talking about structure with respect to the end user. A single page application doesn't necessarily mean all or nothing. So you shouldn't have to download 50 megabytes of SPA just to see a welcome screen. It is very common to have modules by features, and this will allow you to partition your application into focus areas. Then after that, depending on the SPA framework of choice, you can have different loading strategies for the different modules. You can be doing lazy loading, so the specific feature module will only be downloaded when the user and if the user requests it, or you can preload modules in the background. So after you get the main module that will present the welcome screen to the end user, then you will continue downloading on the back end all the modules that he will need to get to next. Some final notes, and I know I may be tiring you guys. You have starting a challenging but very rewarding journey. It will require a lot of commitment on your behalf. So you need to make sure that you surround yourself with people that you feel comfortable asking all the stupid questions. And just keep in mind that there aren't any stupid questions. You need to emphasize on the important aspects. So I've taken the liberty of just highlighting some of those here, but I'm sure that you will find plenty of others in your journey here. One of my favorites is that first you need to make it work, then you make it right, and then if it is needed, make it fast, and then rinse and repeat on that. I mentioned before a little bit about the rules of optimization. The first rule of optimization is don't optimize. The second rule is don't optimize yet. Third rule is, if you need to optimize, first you need to understand what you're optimizing against. What are your pain points? What kind of impact they have? Get some numbers about what those pain points are and how they behave. Then start working against them, and then you can measure what kind of impact you had. Do not assume that you know what the problem is. Chances are the root is somewhere else. Finally, everything should be as simple as possible, but not simpler. You may have heard of it as the KISS simple, the KISS principle. Keep it simple. Keep that in mind. Do not try to overdo what you have. Start simple and then build up. So this is it. Thank you very much for your attention, and I hope that it wasn't too much, and the speed by which I went through most of the slides did not greatly affect the understanding of everybody that is here.
Thank you very much, Giorgos, for this amazing presentation. I see you shared some links at the final page of the presentation where people can potentially reach out to you. So we will also share them in the description of the event, which is recorded and will be uploaded to our YouTube channel tomorrow. Thanks a lot for bringing all these topics. I know that for most of the people here, they might have not heard of some or many of them. So it's great to be introduced to these topics. And as you mentioned at the beginning, we're not going to cover everything in details. We are covering important things, I don't find the word, important aspect of developing a single page application. And then we can later on dive deeper into them. And what I suggest to the people that joined our event today is to use this presentation as a go-to, like whenever you need to think, you are, let's say, thinking of creating an application, like to go to this presentation through the different aspects that Giorgos covered, and when needed, you dive deeper into that specific thing and start implementing slowly but surely. So Anita in the chat said, thank you very much. It was a great and very informative presentation. Thank you, Anita, and thank you for joining us. Shamir, also thanks for the presentation. We can see the messages appearing on the screen. So yeah, I think also some other people brains might be like smashed potatoes right now, but that's normal. That's as you said, this is a very challenging field, but very rewarding at the same time. And as we always say to our students when they are thinking or at the beginning of joining our cohorts or at the beginning of the cohorts, is that it's what you put in, you get out. So as much commitment you put in learning and being resilient, because you will find yourself a lot of times like thinking of quitting, and that could happen on a daily or a weekly basis. But that's part of the journey. But as also Giorgos said, every challenge, every bug, every issue you might face, someone has already faced it. So you don't have to reinvent the wheel. With the globalization, like all the information, all the data is out there. Like it's a Google search away, and now with AI, it's getting even more accessible. Like to have accessibility to the information. So yeah, that's what I wanted to add. I didn't like all the topics were covered nicely, so I couldn't find any more specific question to ask you during the presentation, and that means that it was really nicely covered, Jorgos. So thank you again.
Or it was very tiring.
I will
uh,
stick to the first option.
no, I'm joking. I hope that I know that there was a lot of topics there. I know that there was a lot of information to take in for everybody that is watching. But the point was not to dive into just one thing and just stick to that. There's a lot of resources out there that everybody can use in order to become proficient in an aspect that is bugging them. But my perception, at least, especially for people coming into the technology, into the profession, into all this, is that the sooner they understand the problems, the sooner they will appreciate the solutions. Having a library that will solve a specific problem that you are not aware it is even there, it is great for productivity in some cases, but it is very troubling for your evolution. You need to face the problems in order to understand the solutions and in order to evolve as a professional. So even if some things out of what was mentioned, some frameworks actually cover them to an extent that we are not even aware of them in some cases. It's very important to try and see what is there, what is covered, what we're missing, to understand how we can use the specific approach, the specific tools, in order to build ourselves a little bit better tools.
Definitely, and that makes me think of. I think it was the developer that created Node.js. He has a quote that says, "You will never understand everything, but you should push yourself to understand the concept." And the concept that we were covering are framework and technology agnostic. So if you understand the concept, then picking it will make your life easier and help you select the technology or the framework or the language that will fit better to the needs of your business logic and the application that you are willing to build. So yeah, thank you very much, Yorgos and Diamantis, for joining us today. It was a real pleasure for me. I will definitely go back to the presentation to pick some stuff out of it for myself. And yeah, so I see a message in the Yorgos LinkedIn profile. Yeah. So Dimitar is sharing some information, and tomorrow we will upload the recording on our YouTube channel, and you can share it with people that might be interested in watching it and getting the knowledge that was shared today. So thank you very much again. It was a pleasure.
Thank you.
And
Thank you. And can I say that if anybody has any questions, that has watched it, will watch it, has any questions, or has some comments on what we presented. We'd be very happy to talk with everybody, and we will try to do so.
Thank you very much, Giorgos. And thank you everyone for joining us today, and see you in our next events. And have a nice evening and nice end of the week. Thank you.